Hi, first grade scientists. My name is April Kelly, and I'm so excited you're here with me today. We are going to explore something really interesting about light. Light is something we use every single day, even when we don't think about it. Light helps us see our classroom, our homes, the playground, our toys, our friends, and everything around us. Without light, we wouldn't be able to see anything at all. Just think about when you go into a dark room. With the light off, you might not be able to see anything. But when you turn the light on, you can see. And here's the cool part. Sometimes light can make things look a little different than we expect. Sometimes light shows us things exactly the way they are. And sometimes light can make things look strange or surprising. And when that happens, scientists like you and me get curious. We start asking questions. We start wondering why something looks the way it does. Today, we're going to do a simple experiment using just a pencil and a cup of water. These are things you've seen many times before, but when we put them together, something surprising happens. I want you to use your scientist's eyes and your scientist's brain to notice every little detail. So, before we begin, take a moment to get comfortable, get focused, and get ready to observe, just like real scientists do. We're going to take our time, look closely, and think carefully about what we see. For this experiment, you need a glass of water and a pencil. That's it. That's all you need. This is my pencil. You see it? Just a regular pencil. It is a little metallic green, but any pencil will do. And I hope you can see it clearly. Let's see. There we go. It's straight, it's smooth, and it looks exactly like a pencil. Right? It's not a dinosaur. No, it's a pencil. And here's my cup of water. It's clear, it's still, and nothing unusual is happening yet. These two simple objects are going to help us learn something amazing about light. Before we start, I want you to make a prediction. A prediction is a smart guess about what you think will happen. Let's look at the pencil first. See it? There's the pencil. Look at how straight it is. Look at the color. Look at the shape. You've seen a pencil like this many times. Now look at the cup of water. It's clear. You can see right through it. See the box behind? Here's my finger. The water isn't moving. Nothing strange is happening yet. But what do you think will happen when I put the pencil in the water? What do you think? What do you think is going to happen? Will it look the same as it does right now? Will it look the same as if it's in the air? Will it look bigger? Will it look smaller? Will it look bent? Will it look broken? Will it look like it's in two pieces? Or will it look exactly the same? Think about times you put your hand in the bathtub or a pool. Did your hand look different under the water? Did it look bigger or wiggly? Think about times you've seen a straw in a drink. Did it look straight or did it look like it was bending? Now, scientists, this is your turn. Pause the video and draw your prediction. Draw the pencil and what you think it will look like when it goes into the water. Take your time. Make your drawing neat. When you're finished, press play. Hi, first grade scientists. Welcome back. Now it's time to test your prediction. Watch very closely. I'm going to put the pencil into the water very slowly. Are you ready? I want you to keep your eyes on the pencil as it goes in. Oh! Keep watching. Look right where the pencil goes into the water. That's the most important part. What do you notice? Don't rush, just look. Okay, scientists, let's look carefully. Scientists observe. That means they look closely and describe what they see. Look at the part of the pencil that's above the water. Now look at the part of the pencil that's below the water. Do they line up? Or does it look like the pencil is bending or breaking? Take a moment and really look. I'm going to hold it very still so you can focus. Now look again. Look at the top. Look at the bottom. Look at the water line. Here's the top. Here's the bottom. And here's the water line right here. Now, at the water line, what are you noticing? That's where the biggest change happens. Now, let's look from a different angle. Scientists check things more than once. What's happening here? Does it look like it changes shape? Does it look like it moves? Does it look more bent from this angle? Or less bent? What do you think, guys? Look again at the pencil below the water, the pencil above the water, and at the water line. Look at how the pencil seems to jump or shift right at that spot. See right here? See the water line? What's going on with the pencil? Now let's look one more time, very slowly. Look at the top of the pencil. Now look at the bottom of the pencil. Now look right at the water line. Think about what your eyes are seeing. Think about what looks different. Very interesting. Okay, scientists, let's talk about what's really happening with the pencil. The pencil is not broken, it's not bent, it's still the same pencil. What's happening is that light is traveling from the pencil through the water and then into the air. When light goes through water, it changes direction just a little bit. And when light changes direction, it can make things look different than they really are. So the pencil only looks bent because the light is bending a little as it moves from water to air. Light helps us see things, but sometimes it can trick our eyes. And that's what makes science so fun. We get to figure out why things look the way they do and work the way they do. This experiment is called a discrepant event. That means it's something surprising, something that makes us stop and think and ask questions, just what scientists do. This connects to our first grade science standard S1P1, which teaches us that light helps us see objects and the light can change the way things look, just like the pencil. Look. Oh, it's broken again. Not really broken, that's just a light. Today, you made a prediction. You observed carefully and you discovered that light can make the pencil look bent in water, even though it isn't. I'm so proud of you, scientists. Great job today. You did careful thinking, and I can't wait to explore more science with you next time. You've been great observers. Thank you so much. You have a great day.